Welcome back to my next video. For more videos, click on that subscribe button, and for the latest updates from me, click on that bell icon. And never forget to subscribe my channel as well as to share the videos with your social media friends. And if you like this channel, then recommend to others. Hi YouTube viewers, welcome back to my next video. So in this video I am going to implement the practical implementation of this 6 transistor SRAM. Let us see how it is built. So if you see carefully, this is a NOT gate which is designed in the CMOS technology, because you can able to see that this is CMOS design, right? So in my previous video also I have told you that it is a CMOS design they have implemented. So we have seen the paper how they have done and what the things they have written there. So in this video we will be implementing practical. This is also a CMOS, nothing but an inverter circuit, which this is coupled with here with an NMOS, and this is coupled with it here with a NMOS. Okay, and these two are given to a write bar line, and this is nothing but a write bar, and this is your read bar line. Okay, so read nothing but your bar line and your read actual data. Okay, you will be getting two types of data, real data and also inverted data. So those two data here given it here. So let us open our software called DSCH, so where we will be implementing this module. Okay, so basically we require these two PMOS, and this is like inverted one. As usual, you have seen the diagram. So we'll be implementing a small thing of it. Okay, so now this is like your NMOS, right? Yes, we have got it, and this is like they are crossly coupled, right? So let us take wire and let us implement it. I'll be making the video faster somewhat, so just have a look how I am implementing. So as usual, you can able to see the overall connection of this SRAM has completed right now. And basically you need to see the given, they have fixed, in my previous video I have told that they have fixed the supply voltage to 0.35 volts, right? So I need to fix the VDD to 0.35 volts. Let us fix this VDD to 0.35 volts. Okay, value of VDD we have given as 0.35 volts. Okay, so now actually you need to know the operation of SRAM. This operation of SRAM will be taught you in my theory classes. Okay, so soon I will be launching my theory classes also, theory sessions also. So there you will be learning about SRAM, how it works, DRAM, how it works, and all the RAMs, types of RAMs and everything I will be telling you there. So basically let us see the concept here. As usual, I have told you that SRAM we have that read bar and read line and read bar line, right? Basically one you will be get 1 or 1 you will be getting 0. So it is like basically you need to know that basically SRAM, in SRAM we will be storing in flip flop. This is kind of a flip flop kind of thing where you get logic 1 or logic 0. Okay, depending upon that it works. Okay, so basically now what I'll do, I'll be running this, and let us see how the operation gets worked. Okay, so now basically let us run it. Now you can able to see the both the LEDs like are off, because there is nothing we have on it, right? Write bar we have nothing, we are writing it. So to write the data or to read the data we require this bar to be on. Okay, so if we on, then it will be shorted, and whatever the thing here, the bit what you want to implement or get inside it, then it will be going to the flip flop. Okay, so basically you need to know that to read or write bar line, it is called as read or write bar line. So you will be giving some data. Okay, it may be a logic 1 or a logic 0. You will be giving some data from here or from here. If you are giving from here, this side is true and this is like inverted data, right? As usual, you can able to see the diagram here. Okay, you are giving here from bar, it is right. So you are giving inverted data from here or inverted data from here. Actually, how does it works? Let us see. So it acts as a gate. So whenever up to when it is like 0, the gates are like open here, right? The gates are like open and no data can pass into it. Okay, so whenever I am clicking it, the gate is on, the logic which is inside it will be going inside it. Okay, will be going inside it and it will be stored, and whenever you open it, the logic will be coming out from it. Okay, basically it's an inverter kind of thing. The theory classes I'll be explaining. Now let us see the practical kind of thing. Let us have some inputs kind of thing here also, right? So we require two inputs to write the data basically. So let us write the data inside it by placing small arrangements here, and you go here, right? So now let us run it. Now you can able to see I have on it, and basically why the light is glowing, because here from here it is getting logic 0, nothing but it's a logic 0. So logic 0 is given to here. Okay, logic 0 is given here. So So this is your output, and this is also a logic 0, right? Logic 0 is also given it here. Whenever I give a logic 0 here, it turns on and the VDD comes here, and when the VDD is coming here, okay, the VDD goes here, okay, and it makes VDD is nothing but logic 1 is going here, right? Whenever the logic 1 is going here, it becomes off, right? It doesn't have any connection. So if there is no connection, then my light will not be glowing, right? So this is how it works. So logic 1 and this kind of thing, and if I place this thing and this thing, okay, and if I make it 0, but also 2 light glows because the input is directly connected to your output, right? Input is directly connected to your output, so that's the reason it glows. And if I keep this also, it glows because see, as usual, it is going the same, having the same thing. So logic 1 is given, but there is no connection here, so that's the reason here it is off. And it is storing the data as usual. I told you that it stores the data, so that's the reason it is like on, because already the logic 0 is present inside it, and it is making this to off. Okay, logic 0 is here, so that's making it off, and there is a connection here. From here where VDD comes, and from here also your VDD comes here, but it stops here because it's on, right? It's not turned on because the logic is present inside the circuit. Okay, try to understand, the logic is present inside the circuit. Okay, 0 is present inside the circuit only itself, because these are lines are like on, and but there is no switch connection here, right? If I stop it also, then also there is a logic present inside it. Okay, so it is storing the data unless and until I press this, the logic comes out. Okay, unless and until I press that, the logic doesn't come out. Whenever I press it, the logic gets out. Okay, so this is how your SRAM 6 transistor works. Now we need to see the report, right? Power consumption, those kind of things from here, right? So for that, what you need to do, you need to make a Verilog file. This is a Verilog file which we have given. Okay, so you need to have this module name, like module name as anything you can give, like 6 SRAM 60. Okay, SRAM XT, time scale and maximum time scale, and these are all the hierarchy, critical path, and okay. Just you click on okay. Okay,